Welcome to my channel. I'm Zhang Xu. Let's look at the problem 31 in chapter 22. And this problem is the follow-up problem 29. We can see this time we consider this spherical shell is a conductor. What means conductor? Conductor tells us the charges just distributed at the surface, right? So the net charge is Q for this conductor, and at the center we have a point charge, small q. We need to find the charges at the inner surface of the shell. So we can see, as this tells us this is a conductor. This is Q. So if we consider the electric fields inside this shell, for conductor, we know that the electric fields must be zero, right? So electric fields must be zero if we draw a Gaussian surface. That means the enclosed charge is zero. Agree? Yes. So we can say enclosed charge, this is Q. So that means at the surface, there must be the negative Q at this inner surface. Agree? Yes. The next one, we need to find the outer surface of the the charge on outer surface. So we just talk about the inner surface is a Q. And we know the net charge for this shell is Q. And we know the charges located at this surface. So that means that the net charge is the charge at inner surface plus the charge at outer surface, right? And inner surface is negative Q, so that makes the outer surface is Q plus Q. Agree? Yes. Now, next one, we can write it there. We need to determine the electric field. The first one is smaller than R1, so it's there. So we can draw a Gaussian surface, look like this one. And then we apply Gaussian's law. We can see the electric field times this Gaussian surface equals the enclosed charge divided by epsilon naught. And in this case, enclosed charge is just this Q, right? So we write it there, and then replace the Q enclosed as the small q, we get answer there. The second case is this R is located at there. It's larger than R1, smaller than R2, R0. So we can draw a surface, Gaussian surface, look like this one. As we see, the charge enclosed, this is Q, this is a negative Q, right? Negative Q. So the enclosed charge is zero. And then we can apply Gaussian's rule. The electric field times the Gaussian surface equal to Q enclosed divided by epsilon naught. And this term becomes zero, makes the E equal to zero. Because this is a conductor, the electric field inside the conductor must be zero, right? The next one, we can see the R is larger than R0, so it's there. If it is there, we can see we draw the Gaussian surface. Look like this one, and then we can take a look at the charge enclosed by this Gaussian surface. The point charge Q and the charges on the conductor shell, right? The conductor. So the enclosed charge can be the Q plus capital Q plus small q, look like this one. And then we consider the Gaussian's law. Electric field times the Gaussian surface equal to enclosed charge divided by epsilon naught. Replace the Q enclosed as the capital Q plus small q, we get answer there. Thank you.